All right, so we're going to get started now with the EnergyPro workshop. Day one of actually inputting all of this information into the software. So coming from the building plans for the single family home, we've taken everything, put it into our energy model setup spreadsheet, where we should have all the inputs that we need now to put it into the software for EnergyPro. So what we do to start is start up the EnergyPro software. We're using version 7 for the 2016 California Building Code. And there's two different ways that you could start. There's something called a residential building wizard. You can open this up and it's really helpful. It will guide you through every single input to make sure you're not missing anything. Or you can choose to start from a blank slate and just start a new project. So I'm going to go ahead and start up a new project on EnergyPro. And I'm going to go ahead and mute some people, make this a little bit cleaner sounding. Okay, so we're starting off with a blank slate of this building. And from here on the left-hand side, we're going to build essentially a building tree, starting out with the main building information, branching off into the HVAC, domestic hot water, and then the doors and the windows. Roof and slab, all of that is all going to be organized on the left-hand side. So to start off, we're going to name this building, and let's call it Redwood Valley. This is a new building because it's new construction. For ASHRAE building type, office is fine. It's usually what I use for these type of buildings. Set the front orientation to the front of the building. And again, I determined this from imagining yourself walking out of the front door and whatever direction you're facing. So this one would be 270 degrees. And the primary heating source of this building is going to be electric with no natural gas available. This is kind of an important input for the models, because if you select electric with natural gas available, sometimes it could skew your results. And this is something that's going to be changed in the 2019 code cycle with this software, so that they don't have that sort of bias against all electric buildings. So for this case, we're going to say electric, no natural gas available, and move on. So the next thing that we're going to input is our location. And this is where we find out the California climate zone. So it's the CEC climate zone for the state of California. There's 16 different climate zones. And basically on here, we could just sort through and find our city. So we'll look for Redwood Valley or Redwood City. And that gives us climate zone 3. I'm just going to double check and make sure that Redwood Valley and Redwood City are the same. So it looks like Redwood Valley is actually climate zone 2. So I'll just find something else that has climate zone 2 and use that city. So this makes sure that we have all the proper weather files that are going to determine the energy use of the building. So on here we can put in the project. You'd usually put in the total address information. The designer, we would choose the person who's doing the energy modeling. In this case, I'll just put in my information, it's already saved. The residential tab is something that you could go in and make adjustments on. So if you wanted to get extra energy credits for this building, you could go ahead and select these different HERS measures that would go in. You would hire a HERS rater to go in and verify these things in the building. And one of them would be quality insulation installation to make sure that the insulation is laid properly. The other thing would be envelope leakage testing, where you go through with a blower door and you make sure that everything is sealed properly. So if we went ahead and selected these, this would definitely give us a better performance metric with the California Building Code, just because we selected those. So we'll go ahead and leave them in. And while we're on this tab, the crawl space is one input that we could add from our spreadsheet. So from all of these inputs on the spreadsheet, we took a perimeter calculation, and this is just for the first floor. This is calculating all of the exterior wall lengths. So if we want the crawl space perimeter, we would just add up the perimeter of the exterior walls on the living space and the exterior walls on the garage. And that would give us 237.5. And basically the only other tab on this section that I would go to is the PV tab. And we could input here how much PV we want to get credit for. And we could come back later and add that in. So if anyone just joined, if you could please mute yourselves. That way you can unmute yourselves as you have something that you want to speak out about. Otherwise, I would have to mute you all and you wouldn't be able to talk. So go ahead and mute yourselves if you can. And then we'll go through. So off of this main building, we have some options. You basically right click on this selection and you can add a plant for domestic hot water. And that's really the only selection that I ever have to choose, is just add plant. These other ones are mostly functions for non-res projects, so for commercial projects. Since EnergyPro has the functionality of doing residential and commercial projects, you have some tabs that you don't necessarily have to play around with when you do a residential model. So I would right click that and select add plant. And this is going to be our domestic hot water. So when we see all these tabs on the top, basically this first heating hot water tab is going to be for a boiler. And in this case, it looks like our water heater is an 80-gallon heat pump, which is not a boiler. So we're not going to use this tab, but we will name it right here. We'll do PHW for domestic hot water. And that's where you could just name it. But then we'll go over to this tab called domestic hot water. And this is where we put in our heat pump water heater. So again, this is a new building. So we keep the type as new and we select the product right here. So when we go through, this is the really great thing about EnergyPro is it has these libraries of products that are already input. So when we want to find the product that we actually have, which is the Rheem NEA-rated heat pump water heater, 80-gallon, and we have a model number. The most important things that I would take note of is the energy factor and that it's NEA-rated. NEA-rated basically means that the EnergyPro software has data on how this product performs, so it'll actually show really good compliance with the software. So every time that I add something new, I'm going to click this plus button, otherwise it'll overwrite some of these options in the library. So we click the add new button, which basically just copies something else. And then I'll hit the import function. And these are the different options of things that you could import, and I'm going to select heat pump water heater. So the uniform energy factor, if I sort by the highest to lowest, we could look for the Rheem product. And this one is a XE80T1. So we'll go ahead and select this one that's 80 gallons, and it's NEA rated. So it's already calculating all of the energy information as a NEA rated heat pump. So there's our water heater. And then if you have multiple water heaters, you can multiply it for the whole house. If you had two, you could just put two right there. In this case, we only have one. It's going to be located in the garage. And then for the distribution, we could get credit for this product by saying that we're going to put insulation on the pipes. And these are all the different options that you have for insulation. So the best option, in my opinion, is this selection right here, which is all pipes insulated and HERS verified. So you're having someone that's certified to verify this information. They go on site and they say, yes, all the pipes were insulated with, let's say, R8 insulation. So this way, our energy model is getting credit for that. So our domestic hot water is defined, and then I right-click on domestic hot water, and we select Add System, and this is now going to be where we input our HVAC system. I'll put HVAC for the name of the system. This is a new system, and then under the system type, we'll open this, and here's another library where we can input the type that we want. So from our spreadsheet, we have a heat pump Bryant brand. It's ducted, and we have our efficiency values. So usually I try and match the product the best that I can based on, like, if we could find the exact equipment, that's ideal, but sometimes you can't, so we can play around with the numbers a little bit. But I'll go ahead and copy a field so that I can import a new one into that space. And I select heat pump. And let's say we want to find the Bryant system. We'll select the brand. And this will give us Bryant only products. And then let's see if we could sort through HSPF. EnergyPro is a little tricky with HSPF. Sometimes it doesn't actually show as high of an efficiency rating as the products will go. So the EAR 14.5, let's see, the heating is at 33,000 BTUs. So I'd say this one is fairly close. So I'll select this product, and then I'll just go through and make some edits to it. So this is a split heat pump, so we would keep the system type as split. And I'll go ahead and rename this. So this is a heat pump product. The total heating output, so we're on the heating tab right now, so this is just heating information. We have 33,400 BTU. And then our total output at 17 degrees Fahrenheit. This is information that we got from the spec sheet. Another way about going to find this value is on the ahridirectory.org. It's a website where you can go and look up all the different products and it gives you the efficiency ratings. So for this product, we have 21,710. And then the efficiency is 15 HSPF. And then we'll go to the cooling tab. It doesn't have a BTU rating for the cooling output, so we'll just assume the same. We'll just do 33.4. And for the sensible, could just do half of that value. And then the SEER rating is 20.5. And the EAR rating is 14.5. The next tab that I go through is the controls. So you can say that this fan operates continuously, where that would mean your HVAC system is running all the time. Or you could say that this HVAC system is running intermittently, which is the case here. You're not going to have it running all the time. You're going to be able to turn it off and on. So that will show some credit in the actual calculation. And then outdoor fan or fans. This is where you can make some changes to the product, but it's not common. So we're just going to leave it as is. So there's our Bryant system. We have one HVAC system, so we're going to leave multiplier at 1. And then we go to the distribution tab to talk about the ductwork. So this is a ducted system. And the distribution type is going to be new. And then under the new distribution system, we'll say heating distribution is ducted, cooling distribution is ducted, and the duct location. The attic is a pretty common space for the ducts to be located. And then these are also options that could either work in your favor or work against you for the calculation. And this is going to be your duct leakage. So the standard version would be duct leakage not verified. But the best way to go about it would be, let's see, ducts in conditioned space with leakage to the outside less than 25 CFM or cubic feet per minute. So I think any one of these 3 options are going to be good options to give you an energy credit, depending on what you want to go ahead and test out on. I'm going to go ahead and say sealed ducts with leakage verified, because that's an easy one to do. And then you don't have to do, you don't have to meet an actual target except for the minimum for compliance. And then these tabs, there's an option here where you can get refrigerant charge testing of your HVAC equipment, and that basically makes sure that your air conditioning system is charged properly. We won't do that, but that's an option if you needed to get more, a better performance rate out of your energy model, you could select that. And it's fairly simple for the owner to do, or to hire someone to do. So there's our domestic hot water and HVAC systems that are already selected for the house. And now we're going to right click on the HVAC and we're going to add the architectural components of the house. So when we work with the model, we're going to be looking at this floor plan tab so that we can keep everything organized based on the zones. So when we took all this information from the building plans, we already organized it into the zones based on whether it's on a different floor, different story of the house, or whether it's being controlled by a different HVAC system, or whether it's a garage space where there's no space conditioning happening on that zone. So we've already organized these into 3 separate zones. And when we input these into the energy model, we're also going to have 3 separate zones in the energy model. So the first zone, we're going to go ahead and call this floor 1 living zone. And it's a conditioned zone. It's single family occupancy. This zone it consists of 1 floor. It's all new envelope, new lighting. And on the building story, we're going to select that and input the ceiling height. So our ceiling height is 8 feet tall. So floor 1, ceiling height is 8 feet. Elevation above grade, this is pretty standard at 0.7 feet. This is just the height of your slab. And then your floor to floor height is going to be from the floor of the first story to the floor of the second story. It's usually a foot taller than your ceiling height because it accounts for your raised floor insulation. And then your window head height is just basically how high your window is off the ground, the top of your window. So I usually don't manipulate window head height or elevation above grade unless it specifically says that it's like 2 feet off the ground or something like that. But your ceiling height is always based off of the flooring of your building, not based off of the ground. So we're going to keep this at ceiling height 8 feet, floor to floor height 9 feet. And so that's input there. And then we have a display perimeter. So it separates out the west facing wall area with the rest of the walls. So if our front orientation is west, we'll go on the perimeter just so I can keep track of everything. So the left be, let's see. Can someone spot check me here if I'm doing this wrong? Okay, yeah, that's right. I had to draw it out for a second. So basically going in a circle, if the front is west, then the left is north. Back is east, the right is south. So our west exterior wall length, the perimeter of the west facing wall on the first story is going to be 46 feet. And then I take the perimeter and subtract the west facing wall to get the rest of the wall perimeter. So 99.5 is going to be the rest of that zone's display perimeter on the northeast and south wall. So after that's all set up, I never touch lighting or mechanical or schedules. Those are mostly non-residential, but I do go to the dwelling units tab. And basically I'm going to add the floor area per unit. So we're going to use this area right here for the first floor living zone, which is 1,231 square feet. And there's 0 bedrooms in this zone. And we'll go to the plan set to see, let's see, if there's a kitchen on the first floor. So the second floor has the dining room and the living room. The first floor actually does have 3 bedrooms. So bedroom 1, bedroom 2, bedroom 3 are all located on the first floor. So this is where I'm going to keep track of that. So I'm going to add this up to 3 bedrooms per unit, and it doesn't look like there are any appliances on the first floor. Unless that's a washer dryer. We'll say that there's a washer dryer on the first floor. All right, and then that's it for the zone of floor 1. So now we're going to add the architectural details for all the walls. And we're going to say that there's a room inside of this zone. And the room should be matching up with the zone area. So 1,231 square feet is the area of this whole space. And actually, since we verified that these are actually the bedrooms on floor 1, I'm going to call this sleeping. Okay, and then these options pretty much are good to stay as is. And then I'll right click on floor 1 sleeping, and I'll start adding our exterior walls. So these are all your options to add your exterior wall, interior surfaces that go up against unconditioned space like the garage, the raised floor, your slab, which is your cement foundation on the ground, and then our roof. So I'm just gonna copy, paste, paste, paste. So we have 4 exterior walls. And this front row is the one that we're working off of. So our wall areas are going to come from these 4 selections. And then I'm also going to keep track of our window codes for each of the walls, so that when we input the windows, there's sort of a self-verification system when we go through it. So I'm going to call this our front wall, and I'm going to add the window code. So there's a W02, D13, W04. The area of this exterior wall is 368 square feet. And then I'm going to identify the insulation for this wall. So let's see on the components what we have here. We have 2x6, that's the stud size, and then we have it 16 inches on center, which is the spacing between the studs. And then we have R19 cavity insulation. So we'll be able to add that in, and I'll just select the add new. And this is going to be, well, I'll import it first. So we can import the wall selection. And right here we'll find a 2x6, 16 inches on center, R19. So this is another great thing about EnergyPro is they've got the library selections already there. So all you have to do is click it, and I'll rename it R19. The JA4 tab is it's useful if you want to add interior or exterior insulation to the wall. So if we had R19 in the cavity of the stud and we wanted to add, let's say, like R8 on the outside of the house for some reason, these are usually better for like retrofit houses. You would use the same, like R15 or something in the wall or worse. And then your cheapest way to go about retrofitting that house would be to add exterior insulation. So you'd be able to add that here. And it'll account for it in the energy model. Actually, let's see. You would do it on this tab. This is where you do that for residential Title 24 performance. So you'd add exterior insulation here. JA4 is, I believe, for non-res. And layers also, that's something that you could mess with, and you could show all the different layers in your wall. But this only really works with the non-residential calculations, so I don't bother with it in EnergyPro. But in CBAC Res, you would have more options to play around with this, and it would actually work for your residential model. So for this one, we just click on the General tab, input our wall, and then we select OK. And we're going to do the front orientation. So if our front wall was 270 degrees, facing west, then we're going to calculate the rest of the walls. So if 270 is west, then north would be 360 or 0. East would be 90 degrees, and south would be 180 degrees to make a full circle. So I'll make it easier for me. And then we'll take the orientation of the front wall. This is going to be 270 degrees. Then we're going to do the same for the rest of them. For the left wall, there's no windows on the left wall. So I'll just do that dashed line to make me remember that I didn't forget anything. The left wall area is this blue shaded zone, so it's 215 square feet. And the new assembly for this wall, we already defined it, so now we just get to select it from one of the options. It's the only one there, so it automatically populates. And then this left wall orientation is going to be 0. Back wall, also no window or door codes. The green shaded area is 368 square feet. And we select the R19 wall. Orientation of the back is 90 degrees. And do the same for the right wall. So this has a W05 and another W05 and 214 square feet, R19. And I'll go ahead and save it.
Jenna?
Yeah.
I have a question about the north and the orientation stuff. So if I were to be doing an energy model, but like the house was askew and it's not, like, it's like faced northeast or like northwest, do you like alter the numbers, or do you just assume that it's north facing or west facing depending on? where that lies?
I think if it's within 20 degrees of true north, south, east, or west, you could assume that it's that main direction of north, south, east, or west. But it's always better to use the exact orientation. So let's say it was like 77 degrees was the front orientation. Just add 90 until you get to a full circle, and then just make the calculation add up.
Great, thank you.
Yeah. And if you wanted to do it without the like degrees of a circle, you could definitely use the preset northeast, southeast, whatever. So the right was okay. So I went ahead and added all the windows in so that this would go by a little quicker for the tutorial. So for these front windows, on this one section, I'll just go ahead and input them. I went ahead and opened a new file and just basically have default everything until it got to the point where you're allowed to add a window. And I pre-added all of the windows and doors in here. So for now, we have a W05, and I'm just going to copy that and paste it onto here twice. It makes it so much easier. I'm gonna go through and show you how I came up with the W05 window, and I did this for all of them, and they're each unique to what we have on our Windows tab. So to get the windows, you just right-click the wall, and there's an option to add a window or to add a door. So when I got all of these windows and doors, you add a new one, you name it the same symbol that we have from the building plan. So it's the easiest way to go about it. So you can go back and make changes and it's all synced up. And then the total area of that window for window 5, it's a 60/30 window, which is a total area of 18 square feet, and it's a fixed window. So I added 18 square feet, surface type is new, and when you add a new fenestration, it usually shows as undefined, and you select this so that you can add your new window. And basically, just like any other input, you would add new, and then you get to make up your own window. So I titled mine with the U value that I wanted and the SHGC value that I wanted, and said that it's fixed. So it's a manufactured window. Otherwise, you would say that it's built on site or field fabricated. Manufacturer is the most common type. Visible transmittance 0.5 is a default value that's accurate for most of the time. So I kept it as that. For the U factor, the default is a pretty bad performing window. It's going to be the bare minimum window that you could possibly get away with. But for these cases, we have really well insulated windows. The lower the U value, the higher the insulation. So we selected NFRC labeled, and we gave it a 0.25 U factor. And then for SHGC, I just hard-coded the 0.25 again. And we're saying that this fenestration type is a window. It's a double pane window, dual pane. It's the most common efficient windows are vinyl. So I went ahead and said that this is non-metal. And instead of selecting this as operable, I left it empty for a fixed window. Then when I did the other window types that we have, there's another one for an operable window, and everything's the same except this option is selected for operable. And then for the glass door, it goes in as a window as well, because most of the square footage on that surface is actually a window. So everything's modeled the same. It's operable because you can open it, and the only thing that changed there is the fenestration type as a door. So I'm going to go ahead and select the, what was W05 again? It's fixed. And select OK. And then after going through the building plans, I noticed that it does have an overhang. So I went ahead and added a 2-foot overhang to everything. And I found that on the building sections where you see this little line that comes out on all the different sides of the building. And when I zoomed in with my ruler at a 1/4 inch for every 1 foot, it came out to be a 24-inch overhang or 2-foot overhang. So on all the windows, I went ahead and said that it has a 2-foot overhang. And these are input in there already. So I just selected their the library value of a 2-foot overhang that's 0.1 foot above the window. And the horizontal projection is what makes it a 2-foot overhang. And there's cases where you could say that it's like, if it's the whole rooftop, you could say the whole distance of the rooftop on the left side of that window and the whole distance of the rooftop on the right side of the window. I simplified it and just said 2 feet past, because in my opinion, it's good enough. Same for a side fin. If there was something that was blocking the side from like a west-facing glare at the end of the day or something like that, you'd be able to input that as a side fin just the same way. But in this case, we don't have one. So that's how I got all the doors and the windows, and it's going to be really easy for us because we could just drop them in. So for the front wall, we have a W02. I'm going to copy and paste. There's a D13. DW13. So it's a window inside of door 13. So copy and paste. And then W04. So now all of these are added with their square footage. Left and back don't have anything. The right wall has 2 of them. And then I'll go ahead and save that, and that's everything complete for the walls. And then we're going to add a raised, let's see, going back to the floor plan tab, let's see what we have on here. So there's a connecting wall on the left side of the building. The connecting wall area is 192 square feet on the left wall. So it looks like I didn't do this calculation before, but I need to do it now. So from the exterior wall area on that left wall, since it's not the whole wall open to the outside, it's not all an exterior wall, we're going to go ahead and subtract this connected wall area. I'm undoing that because that's not the right way to do it. So I'll take the exterior wall length and subtract the connected wall length. And so these are wall areas that have changed. So when I go back to the model, I'm going to change this by taking the left wall area and turning that exterior wall area into 22. And then I'm going to make an interior surface that's that connected wall on the left side. So this is the left interior wall. And this is 192 square feet. And I'm going to open up the plan set just to visualize what we're doing here. This is connected to the garage. So this is why we have 22 square feet of wall area that's open to the exterior behind it. And then the rest of that left facing wall has the garage behind it. So it's considered an unconditioned space behind it, and it's going to model differently. So the left interior to the garage is what this is. And we'll go ahead and say it's R19, but it's probably going to be like R15 or something because it has that buffer space, but we'll go ahead and say it's the same. The floor elevation is the same as our first floor zone, which was 0.7 feet above grade. And this garage, this interior wall is adjacent to the garage. So after we build the garage, we're going to come back here and select it. So don't let me forget that. On floor 1, that was the interior wall. The next thing we have to model is the slab. And let's see. I would say that's a slab on grade. It's not a raised floor on stilts or anything like that. So we look at the total area of that zone, and that's going to be the total slab area. So coming back to this floor 1 sleeping zone, we're going to right click and add the slab. Slab on grade. The total area is 1,231 square feet. And the assembly, we're going to import a slab on grade. And the most bare minimum slab on grade that you can model is something that's unheated, which means it doesn't have any radiant floor pipes going through it. And also it's uninsulated. So in this case, I'm going to say it has no insulation around the perimeter of the slab. And we're just going to say unheated slab on grade. And then okay. And then we do the perimeter again. So the exterior perimeter of this space is 122. And did that automatically update from when I changed this? I'll have to go double check that. But we'll say 122 is the exterior perimeter. Condition 20% exposed is pretty standard. So I'll leave that. And bear with me for a second while I go back and double check the perimeter since I changed that value. Let's see, it was the zone. And the west facing perimeter was 46. So total perimeter minus the west is 75.5. And then one more time, we're going to change the total perimeter of the crawl space of all the exterior walls on the first floor. So 213.5. And if you guys have any questions about that, please let me know. But should have done that sooner in the spreadsheet, so I just had to do a little fix right there. So now we have all the exterior walls. We have the interior wall to the garage, slab on grade. And now the only missing wall for this sleeping space is going to be the ceiling. And I'm going to go ahead and link that up afterwards when we do the second floor. So that's going to be missing for a moment. And now we're complete with the first floor sleeping. And now we're going to model the garage. So the first floor of the garage is going to be a separate zone. So on the HVAC zone, we could go ahead and add zone and do it all over again. We're going to call this floor 2. Oh, sorry. Per 1 garage. And the zone type is not conditioned because the space heating and cooling equipment doesn't waste its energy by heating and cooling the garage. So it's indirectly conditioned, but this software has an option to say residential garage, so we're going to select that. It's single family occupancy. The building story is on the first floor. We'll just double check. Everything's the same as the first floor sleeping zone. And then the display perimeter of this space, we're going to change that also. And before I go into any of this detail, I'm going to double check so that we don't do this again. So I'm going to go back to the building plans and check that that right wall of the garage is not double accounted for. So when we see the floor plan, the left interior wall of the first floor space was already modeled. So the garage actually doesn't have a right wall that we have to input here. It does have a front wall, a left wall with 2 doors, and a back wall. So when I do the spreadsheet, the exterior wall length on the right side is actually going to be 0. And that's going to change the exterior wall area and the connected wall area, which we already accounted for. So now that those are automatically calculated in with the perimeters and the wall areas, now we can start again and do this residential garage space. So again, this west-facing perimeter of the garage is going to be on this exterior wall length. So we have 22 feet on that west-facing wall. And then I take the total perimeter minus the west-facing wall. So we have 46 feet for the rest of the sides as the display perimeter. And then I go to the dwelling units tab. This has no bedrooms in the garage space. And there's no appliances either. So I unselect all this. The floor area, I'm not really sure if this calculates either, but I put it in anyways. So 528 square feet. And then we're going to right click the garage, add the room, which is basically identical. We do 528 square feet. For the garage, and then since I have all the orientation and everything completed, I just like to copy the front, copy the left, copy the back, and make edits to it. So the front wall of the garage space, we're going to read off these window codes and then change the exterior wall areas. But the orientation is going to stay the same. So for the front wall of this garage, we have a W05 window. And the area of this wall on the front is 176 square feet. I'm gonna go ahead and change this because it's pretty rare that people actually do like R19 on a garage space. So I'm gonna decrease the insulation. It's pretty common that they have no insulation in a garage wall, so we'll just go ahead and say that. We'll say 2x4, 15-inch on center, R0 garage wall. And then the W05 windows, we could just select this and on the keyboard hit the delete button to delete these out. And I'll drag a W05 window. So copy, paste. And the left wall has a G1, G2, 192 square feet. And we'll select that garage wall. The back wall has a D04. And the square footage of exterior wall area is 176 square feet. And I'll change to R0. I'm gonna save this and go back and get these other windows in. So the G1, G2 is gonna be our garage doors. And I have that pre-selected as a garage door. So I'll copy, paste. Paste it twice. And on this one, I just added the selection under the doors. You can choose to import a garage door. So it's an uninsulated garage door that I chose from the pre-selected library options. I'll just make it consistent and call it a G1, G2. And then the back wall has a D04, so an exterior door that I'll copy and paste. So the garage has all of these walls, and then the right wall, we're gonna link from the floor one sleeping zone. And it's adjacent to the floor one garage. So that's saying that this interior wall is connected to this whole space, this whole room. And then we're gonna give the garage a slab on grade, and the total area of the garage space is 528 square feet. It's a slab on grade. And the exterior perimeter of the garage is 68 feet. Default 20% exposed. So now that we have the floor one completed, separated into two separate zones, now we're going to add the second floor as our third zone. So right-clicking on the HVAC, we could go ahead and copy and paste this and just change fields out. To me, it's a lot easier to do that. So we'll copy and paste it under the HVAC section, and we just have to make sure we go through everything and change it up. So this is floor 2 living zone. And we'll take a look at our building plan to see what it is that we're working with again. So that was floor 1. And it looks like before we get into this, we should model out the roof of the garage, because it's not all living space above. And it looks like the other side over here has some roof that we should be accounting for as well. So on the second story of the house is where we have the living room, the dining room, and the kitchen. And then the deck is 480 square feet. So it looks like that's going to be the area of our roof on the first floor that's open to the exterior. And then the roof of the garage is going to be 500 square feet. So I'd say let's go ahead and add that in as we go. So floor 1 sleeping zone was this right-hand side, not including the garage. And if the deck is 480 square feet, I'd say that would be a safe assumption, so that we can right-click floor 1 sleeping, and we're going to add a roof, and we're going to do 480 square feet. The assembly, we're going to add a new field and import a roof. Since this is not an attic type roof, it's a wood framed rafter. Looks more like that. We're going to select that option, and we could go ahead and say it's a R30. What's our spreadsheet say? We have R38 2x10 at 24 inches on center for the roof. So if that's an option, we'll go ahead and select that. So 2x10, 24. It only lets us get to R30. So we could just go ahead and select 2x12 at 24 and get R38. See how that works. And if the client is going to be using, let's say, like Energy Star certified roofing shingles, or something that is going to reflect the radiation, we can select CRRC1 certified roofing, and we'll be able to input these values for age solar reflectance and thermal emittance. For now, I'll use the default values, but it's pretty standard that most people in hot areas will have a CRRC roofing type. So we'll say the roofing type is lightweight shingles, like asphalt shingles. And then we'll go ahead and select OK. So the orientation of the roof, I usually match that with the front of the building. So it's 270 degrees. The slope is 0, it's a flat roof. And then I'll go ahead and save that. So since I have 1,231 square feet, I'm just going to kind of keep track of this somewhere. So 31 minus 480 is 751 square feet that's left over for that whole first floor zone. So the plans are saying that the whole second floor zone is 760 square feet. That's pretty close to that calculation. So that'll give us some direction when we do the second floor. So the first floor has all 4 walls, an interior wall, a ground, and a roof. Now the garage is missing the roof space, so we'll just add that really quick. We'll do or here, I'll just copy and paste. So we have all the details of the type of roof. And then we're just going to change the area. And they're saying that it's 500 square feet over the garage. The area that we got for the garage was 528. So could use your best judgment for that. I think if we use 528, we have all the calculations to back it up. So I'll go ahead and use that. So now, ideally, we have all 6 surface areas of the whole first floor accounted for. And now we'll do the second floor with the living zone on the second floor. So we're starting off on that zone tab. So we have it's a conditioned space, single family. It has only 1 floor, but now we're going to change the building story to the second floor. So it's only focused on the second floor of this building, even though it's only 1 story within this zone. So floor 2, we're only multiplying it by 1. The ceiling height is still 8 feet above the floor of that zone. Elevation above grade is going to be our floor-to-floor height plus the first floor's elevation above grade, which was 0.7. So I have that saved in here as 9.7. Floor-to-floor height is still the same, and window-to-head height is still the same. So floor 2 is 9.7 feet above grade. And we're going to change these perimeters now. So the west-facing wall of the second floor is 20.7. And then the northeast south equals the total perimeter minus the west facing. So we'll say 113 or 112. 0.7. Dwelling units. The floor area of this zone, where are we? So we don't have a slab, we don't have a raised floor. Oh, we do have a raised floor. The roof is 786. So I'm just making the raised floor equal to the roof. So the floor area of this zone is 786. 1 unit, and there's 0 bedrooms in this zone. There is a range. This is an all-electric house, so it's electric fuel. There is a refrigerator, there is a dishwasher, there's no washer or dryer in this zone. One more thing to mention, I'll go back to the dwelling units tab real quick. If you have an energy recovery ventilator, ERV, or a heat recovery ventilator, HRV, you would input that in the dwelling units tab by choosing a non-default indoor air quality fan. So you would look at a spec sheet for that product and you would look for the airflow, the power, and the heat recovery efficiency. And this is where you'd be able to input that like special type of indoor air quality fan. Otherwise, we assume that all of the ventilation for the houses are being served by like a whole house bathroom fan. That's usually how all the models work, is just using that as the default. So if you have more than that, you would choose your non-default IAQ fan and you would input these special feature information. We're going to skip that for this house. And now change these other fields. So floor 2 living, the area is 786 square feet. The front wall, get our new window codes. The front wall has a W10 and a W11. And the front wall is 165 square feet. Same type of wall, same orientation. But we will delete these old ones out. So the left wall has a D22, a W09. The area of the left wall is 368 square feet. No other changes. And the right wall is W07. The area is 368. And no other changes. So deleted out the other things that were copy and pasted from the first zone. So now we've got our exterior walls input for the front, left, back, and right. We'll go ahead and drag and drop our window codes or copy paste. So D21 is missing. Let's see what that is. So D20 equals D21. So D20 and I'll just rename it DW21. W08 is the last one on the back wall. Okay, so this automatic calculation is saying that our back wall area is not large enough to hold these windows. So we have 212 square feet for the back wall. 60, 10. Wow, yeah, that's cutting it really close. Since I don't want to mess with the geometry of the building, I'm just going to try manipulating these a little bit. See if that works for us. And then the right wall is W07. Copy and paste. So now we have 786 square feet. And this is saying it's 760 square feet. So let's go ahead and use our values. And we're going to call this an interior surface. We're going to do the floor now of the second floor. And the raised floor option is something that you would use if there's like a balcony on the second floor that has conditioned space on it. So if you have like the second floor that's basically just above the exterior of the house. So in this case, we're doing a second floor that's above conditioned space. And so we're going to call it an interior surface for the floor. So floor interior surface. And we're going to go to the floor plan and look for this area, 786 square feet. We'll say that this is an R19 floor. The floor elevation here should match the elevation that we selected for the second story. So elevation above grade is 9.7 feet. So we'll select that same elevation here, make it consistent, and then we select adjacent to the floor 1 sleeping space. So that connected this ground floor of the second floor to the whole room of the first floor. So we have front, left, back, right. We have the floor, and now we need the roof. So I'll copy this roof and paste it down here. And we'll make it the same area. So 786 square feet. And everything about it should be the same. We can double check. Yeah, so it's still a flat roof. And everything should be the same. So we have 6 sides on every zone. We have 3 zones that are all underneath one HVAC system. We have the garage specified as it not being conditioned. It's a res garage. So these 2 are being conditioned by the HVAC system. And the whole house is being served by the domestic hot water system, which is the 80-gallon Rheem heat pump water heater. So as a reminder, the extra features that we have in this home, we have quality installation testing, envelope leakage testing, and we did not select the refrigerant charge. So now it looks like we're ready to start our calculation. Does anybody have any questions about where we're at now? Because that's pretty much everything finished with the model. If there's no questions, then I'll show you guys the calculations that we do. So after you finish the model and input everything that you need, then you go down to this calculations tab, and we're selecting Res Title 24 Performance. So that's the whole calculation that we just added the inputs for. And then once that Res Title 24 Performance is selected, then we go to the reports, and we're going to select which reports we want this calculation to print out. So this CF1R form is the one that we're familiar with looking at the building plans before. It has all of our inputs for Title 24, and it will give us basically a summary of inputs and show us our performance above standard. Some other options that are good to have on here, I like to select the form Econ 2. That'll show us the total annual energy use of the house, and so we could size the solar array. So I'll select the CF1R, the Econ 2, the project summary is nice to have, energy use summary is also nice to have. So I'll select those, and then we hit save and calculate. So the software will select, it'll see if you have any errors, and in this case we do. We have an HVAC system error. So we said that the HVAC ducts were in the attic, but there's actually no attic that we modeled. So the solution, it says, is increase the area of the attic by editing your roof or change the location of the ducts. Easy enough. So we're going to go back to the HVAC. And under the distribution, I do remember we said the ducts were in the attic, but it's a flat roof, so there's no attic. So we're going to go ahead and say that the ducts are in conditioned space. If you imagine the whole house just like a big balloon, if there's no attic space, there's no unconditioned space in the house except for the garage. And the ducts are not all going to be located in the garage. So the ducts are located all within conditioned space. So now that we have that option selected, we should be able to save it and do the calculation without any errors. Oh no. Okay, so this error is saying that I should not select QII. So we'll try that and save it and try to calculate again. So the other errors are for all of my windows. It says in the building tree, the window W02 has no height specified. Oh, that's right. So it looks like I was being too quick on the windows and I forgot to do the surface geometry. So if you just input a basic window, you can get away with doing everything how I did it. But when I add an overhang, there's an option that pops up that I should have noticed, and it's wanting you to input this XY position for the shading devices. So it wants you to say explicitly how wide is your window and how tall is your window. And that's just because I selected overhang on everything. So if I remove the overhang, for example, this surface geometry will not matter anymore. It looks like the model is still going to run, even though those windows are showing all these errors. But I'm going to go ahead and show you guys a fun tip on changing, like doing a global edit. So I'm going to go ahead and take all of these windows out and say that there's no overhang. And we'll see what happens. So as reference, though, it looks like it did run. So our calculation of the standard energy model, so this is the same exact home, same geometry, only all the energy inputs are going to be different, that are just going to barely meet the California Building Code minimum standards. That's the standard house. So it's not any savings, it's no benefit, anything like that. The proposed house is what model we actually did. And you can see the variation of like how much better our proposed house is for the heating elements, for the cooling elements. These values don't really change, but we want to pay attention to space heating, space cooling, and domestic hot water, because those are the values that are going to really change our energy intensity. And these are all in the metric of TDV energy use. So it's 1,000 BTUs per square foot per year. And it gives a total TDV value, which is then used to give us our percent above compliance. So this is a 29.6% better than standard home. For like zero net energy, all electric buildings, this is really great performance. For a lot of the rebate programs, they need you to have at least 20% better than standard. Most builders will just try and get the bare minimum of like 0% better than standard. But if you're paying someone to do performance modeling for you, you want to make sure that you're going to be able to get like a high performing home. So 29.6% is it's pretty much on like one of the highest end homes that you can get in regards to performance. I think some of the highest metrics for this in 2016 code is maybe around like 35% is some of the highest performing homes, just because 2016 code got a lot more strict. So this is performing pretty well, I would say. And just to finish up and try this now without those overhangs so that I get rid of these 20 warnings, I'm going to go ahead and show you guys how to replace all the windows. So we could do this global edit with a lot of different things. You could do a global edit of all the walls. Let's say you wanted your walls to be like R21 instead of R19. You don't have to go through and change every single wall. You can do a global edit. So you click on edit and then replace. And in this case, we're going to choose fenestration for the window features. And we're going to select the overhang. So if I find a 2-foot overhang, I want to replace it with, can I do 0 overhang? Let's see if this works. I've never actually tried it with just an overhang before. I've done it with windows. So then you click global, so it gets all of them. And then it'll say it replaced 10 occurrences. So let me see. Now for the windows, it has 0 overhang. I think I would rather just hit the delete button, but we'll see if this actually works. Let's see if it still gives me the errors. Yep. Okay, so yeah, I'm not going to waste any time doing it now, but for future reference, if you do mess with the overhangs, you're going to have to not just input the total area of your windows, but you're going to have to input the window width and the window height specifically. And then you won't get 20 warnings. So that is the end of the energy model in EnergyPro 2016. It went by pretty quickly. We did that in like an hour and a half. So I think the setup spreadsheet is definitely helpful in making everything go by a lot smoother. Also, it's great to have the reference when we work backwards and have to do changes or anything like that. So thanks for joining, everybody. And feel free to unmute yourselves if you have any questions or comments. Next week, I'm going to ask Emily to help out with doing a CBEC model. So next week, we're going to be working through this whole process again in CBEC Res 2016, just to see the different functionality. And then that will set us up for the future talks when we transition out of EnergyPro and into CBEC Res. Because for the thermal energy modeling, thermal storage energy modeling, a lot of those features that we're going to do, like kind of like the high level training on for the next later workshops, those are all going to be behind the scenes with the coding of CBEC Res through the CSE.
Hey, I got a quick question.
Yeah.
So what did you specify for ventilation again?
I did not specify ventilation. So under, where was it? The zone tab.
Mm-hmm.
So let's say in the sleeping zones, you wanted to have like an HRV. You would go to the floor 1 zone, and on your dwelling units tab is where you would be able to say, no, I don't just want the basic like whole house fan in my bathroom to be accounting for ventilation. I want to add ventilation aside from the HVAC system. For example, HRV, ERV, or something along those lines. you would
Okay.
put that information here based on spec sheets.
Right. So where's the IAQ fan specified? Or is it just like a default? You don't necessarily have to change?
Well, the indoor air quality fan, it's like code minimum to have a bathroom fan. So we don't have any of those really specified in the energy model. It is all based off of like inner calculations within the software for a default fan. So if you wanted to bypass those default calculations that are working behind the scenes in EnergyPro, then you would select your non-default IAQ fan, and you'd be able to input the information. Otherwise, you can't really mess with that feature.
Oh, I see. Okay. Yeah, because I was kind of drawing similarities to CVAC Res. And in CVAC Res, they have both the like IAQ fan and the whole house fan. So, yeah, the whole house fan, it seems like that's what you're just saying, the like default requirement to like meet ventilation stuff. So seems like they both softwares have that function.
Yeah.
That makes sense. Yeah.
Yeah, I'm pretty sure CBEC probably has more features that you can select.
Right. Like within CBEC, I guess I'll show you guys next week. It has like both, like on the building tree, it has like an IAQ fan. And then I think the whole house fan is kind of like built in, whether or not you specify one or not. But like you could probably specify one and like, make it more powerful or something like that.
Gotcha.
Right. Okay. That answers my question. Thank you.
Yeah. And while we're here, since we're a little early, might as well print out our findings. So to get those reports that I selected, we would hit the file button and then print. And this is going to print out those reports, the CF1R, the Econ2, and anything else we selected. So this is our certificate of compliance, and it's showing that we're 29.6% above standard. It gives a breakdown of our whole building, and it breaks down every input that we selected. So by naming things the way that I did, like the roof and the walls, for example, I find it really helpful to just type out what we chose, so that when you go back later and you're reviewing this report, you can actually see what's selected. If you just select, like, if you don't name the type of roof or you just put R38, that's fine as well, but I think it's really helpful for anybody who's reviewing the reports when you explicitly type out exactly what you selected for that roof type. The window codes on each of the doors, that's not too helpful for everyone who reads the reports. I think it might be helpful for people at rebate programs who are going to be reviewing, so they can kind of like reference, oh, that's a front wall, these are all the windows that are on that front wall. I think it helps. I'm sure it helps someone, but definitely helpful for me as the modeler when I go through.
I have a question about, going back to Emily's question about the ventilation system. So like, when you're doing retrofits, is it commonplace to model the house as is, with like all of the building standards, or like how the house is with like all of the different things that are in there? Does that make sense? Like before you model thing as like a baseline?
Yeah, so I could show you real quick in the model. So if you're, instead of doing a new construction home, which is what this model was, if you wanted to do an existing home, and let's say you're adding to it, let's say you're like adding a new heat pump, like HVAC system, or you're adding new ducts, or you're adding to the walls that's increasing your conditioned floor area, you would change your building type to existing plus addition and alteration. They call that E plus A plus A model. So that's one option for it. And basically when you do this type of model, let's say I select it right now, every option on here, it gives you a type where on the new construction, it defaults to new. But if you have E plus A, you would specify what's existing, and it gives you a whole other field. And then you would specify what's new, and it stores that, and then it allows you to input your new system.
Oh, that's cool. So then you don't have to go run it once and then alter it to the new standards you have.
It's helpful when you're going through like the building department. That's the way that they prefer it to show, so that you can see what's existing and what's altered. Another way to go about it is if you do either existing or new, I'm not sure exactly, but let's say you model everything as is and then you wanted to make changes to it. You can go to the Res Performance tab, and you can run different energy measures. If you were to change things, you could run these alternatives.
Okay.
So if I have a home modeled, and let's say that on this building type in the very beginning, let's say that I say everything is existing. So like my existing home. I input everything as is and select existing on every option. And then under my calculations, instead of doing Res Title 24 performance, I just do Res Performance. And this is bypassing your Title 24 requirements.
Oh, okay.
Just doing the performance of the building. And these are how you can specify your alternatives. Like it'll say that I have an existing HVAC system. Let's say it's like an old wall furnace, gas powered, and I want to update it. So I could run different alternatives, and then when I select one of my output reports, it'll show your site savings based on the energy consumption of your existing product versus the energy consumption of these alternatives that you run. And you can run, let's say, 6 alternatives side by side, and they would show up in your Econ 2 report, which looks like this. And it would be under your recommended improvements. You would have like your new heat pump system saying that it's replacing your old wall furnace. It'll say your annual dollar savings, and it'll give you your site and your TDV savings.
Okay.
So that's one way where you can model an existing home and run alternatives to see your percent improvement based off of your existing conditions.
So for like the existing conditions, I think my question has to do with like, let's say you have a really old house and it was built a long time ago, so like 50 years or something, and then like you have all of your insulation stuff. Does it account for it degrading over time? So like there'll probably be more, if it was poorly built, there's probably more air infiltration, outdoor air infiltration.
That's a really good question. I don't know about degrading over time, but they do have vintage tables that are in the standards. Let's see. So in the compliance manual, they have vintage tables like this. So let's say your home was built in the 50s. If you don't know what any of the wall insulation is and you don't want to go in there and look, you could use all of these inputs for your existing conditions. And these are based off of how the building code was
back then.
Yeah, back then.
Oh, okay. So like, yeah, because I could see how it would be dangerous, like if it was built in a time where they used asbestos or something, or and they didn't necessarily want to um, dig in there.
Right.
Cool.
Yeah. It's pretty wild though that for gas furnaces from 2016 all the way back to 1978, it's the same efficiency rating.
Oh wow.
It's pretty wild. It's still our federal minimum. So that's got to change. That's wild.
Hey, Jenna,
Yeah.
I have a question about modeling cost.
Sure.
It wasn't totally obvious to me looking at the econ report.
Mm-hmm.
Is that part of the model output? How much? So I see energy savings, but does that also translate to cost savings?
Let's see. So on the bottom of the report, is that what you're looking at, or at the top?
Yeah, like I see energy cost and it's all zero.
Right.
Do you have to do some sort of comparison, like an addition or something like that, to be able to see that information?
Yeah. So let's say that in the energy model, if I had selected existing conditions, or I'm pretty sure I could do it now as a new construction model, then you select your alternative measures, and then it would start to calculate these. These aren't calculated in the Res Title 24 performance calculations. This is mostly filled out when you do just Res performance. So the one thing that I like to get from this document, no matter whether you do it in Res Title 24 performance or Res performance, is I'll get a total electricity kilowatt hours per year for the whole house. This is like the energy consumption of the house as modeled. And this is kind of a quick way to get like an estimate of how much solar you would need or how much energy you consume throughout the year. You could do like basic calculations to figure out your the kilowatts of your system. So if you wanted to break down the total cost to run everything, there's additional features that I did not include here, and that would be on the utility tab. You need to define your utility rates. Based on your baseline territories. So we could actually do this really quick. If it's PG&E, does somebody want to look up Redwood Valley zip code? Or wait, I think I have it right here. 95470 PG&E territory.
There's also a clever website, zipmat.net. It's useful.
What is that all about?
It tells you the zip code for everywhere in the US if you type in an address.
Ooh, nice. So this is considered baseline territory X. And I think I have a territories map. So if you wanted to look at like a quick way to find the baseline in PG&E territory, this is where you find all of those letters to differentiate what territory it's in. So the Redwood Valley is in territory X. So we would go on to EnergyPro, find PG&E electric X territory, and import that. So this is importing all the rates. of this baseline territory. And then fossil fuel is undefined because it's all electric. So that's one piece of the puzzle that you would need to include the cost of running this equipment. You would need to add that, and then you would need to select your calculations as res performance and add in some alternative measures. So let's say we want to like add refrigerant charge verification, and we want to add additional floor insulation. Oh, that's only doing a raised floor? Maybe not. I want to add like additional roof insulation to say like R49. Let's go wild. See if this actually works. So if we select those two alternatives and we do run measures combined together, we save this. Let's see if this will show us an econ 2. So if we do refrigerant charge verification, it'll improve our performance by 0.2%. If we do additional roof insulation, it looks like we capped out on like the efficiency, like the cost efficiency of doing that. So I don't think it gives you a benefit because I don't think that much insulation is necessary. I could be wrong, but I'm curious to see if it'll print out a report that shows. Oh, right. So res performance is the one that I need a report for now. And let's do an econ 2. Undefined. Yeah, honestly, I don't do this often. So, oh, I'm doing this in the Windows tab. I'm messing things up. But we could bring this on to another session and dive into this.
It looks like utility bill summary might be useful to you.
The utility bill summary?
As a report?
Oh, gotcha. Yeah, and actually when I was doing a lot of these with the utility information, these schedules aren't actually accurate for the rates. I had to go in here and click on utility rates and add in these special features. So like when you go on PG&E's website and you download their rates for general residential electric, there's a meter charge it's shown on there as a daily charge. And you have to convert this to monthly, so you multiply it by 30, and you get the meter charge. That's your upfront cost. And then in here, you have winter rates and you have summer rates. So you have to input your information for the different tier levels. So for the winter rates, if it's an all-electric house, there's different winter rates than if it was a mixed fuel house. So on the PG&E general rate website for residential, you'll input, let's say it's like 14 cents a kilowatt hour, and you have an allotted value of like up to like 500 kilowatt hours. They'll let you pay 14 cents a kilowatt hour. Once you go above that limit, they'll charge you more, and then you have another limit. So like I wouldn't entirely rely on these being accurate, because when I've done it before, they're off by a little bit.
Is that regardless of whether you have an all-electric house? Those limits are the same?
When you download those rate schedules on their website, there's different values for an all-electric house than for a mixed fuel house. And you might actually have to hunt that information down. But when you're doing a basic model for compliance, I don't mess with the utility information because it's pretty much useless in my opinion to like go through the hunt to find all of that. Unless you're going through and you're doing these energy features, or if you're doing some form of like research where you want to input your results and get like a good cost analysis. That's the only time that I would really go through and spend the time to kind of like hunt all of that information out. So if we, yeah, we could definitely come back to some of these topics, and if you guys want to email me anything else that you're curious about, we could definitely take requests for future talks. And we're doing a deep dive basically to keep track of all this information that we've gathered throughout the years on the heat pump studies and doing these changes in the software for future people who are interested in joining the team. So always room for more information. Let us know. And yeah, it looks like we're up at time. So thank you all for joining today.
Thank you.
And
Thanks,
yeah,
Jen.
yeah, thanks for being here. And again, just feel free to email me if you guys have any other questions or anything like that.
Okie doke.
All right. And then I'm going to